to my math YouTube channel. In this video, I want to show you how to actually transform this complex number, which is raised to the power 12, into a simple standard form where we can clearly see the real part as well as the imaginary part. Guys, there are more than one ways of actually doing this problem. One way would be to write this out 12 times because it is raised to the power 12 and keep multiplying each term. But guys, we can already see that that is going to be a lot of work, and that's not the most efficient way of actually doing or simplifying this problem. Guys, the other way is to kind of first transform the piece or the complex number inside the parentheses into a trig or a polar form, and once we have it in the polar form, then we can use this Moivre's theorem to actually simplify further. From that, we can break it into a real, or we can transform this into a real part and an imaginary part. So guys, let us start that process. First of all, what we are going to do is I'm going to transform this piece inside the parentheses into the trig form or the polar form. For that, I have to, let me start by writing z equals to 1 over radical 2 minus I times 1 over radical 2. From here, I have to first identify, guys, I'm trying to transform this into a trig form. So to do that, we have to take some steps. Step number 1 is to identify the real and the imaginary part. The real part A here is 1 over radical 2, and the imaginary part is going to be negative 1 over radical 2. Based on that, first thing we do is we try to plot this in a complex plane. So let us go ahead and first do that. So if this is my complex plane, this is the real axis, this is my imaginary axis, and 1 over radical 2 and negative 1 over radical 2 obviously will be on the fourth quadrant, and so it would be somewhere right here. And then I draw this, we can draw this reference triangle, but we know that the angle that we are actually looking at is this whole angle, and we call it angle theta. Sometimes for convenience, we also think of this angle as reference angle theta, but guys, here we're just going to consider this whole angle as theta, and that is what this is because the angle is always measured with this as the reference side, right? So it is from here all the way to here. So let's not confuse ourselves. This is the angle theta, and guys, this is going to be 1 over radical 2. This is like my A equals to 1 over radical 2, and this B is going to be negative 1 over radical 2. Keep in mind, these are not the side lengths. If these were side lengths, then they were supposed to be positives, guys. These are more like coordinates, and you can think of these as ratios as well. Now, in order to write this or transform this into the trig form, let us rewrite the trig form. Guys, the trig form looks like this. Z equals to R times cosine of theta plus I times sine of theta. So there's two things that one needs to in order to write the trig or the polar form. The first thing is we need to know the R and then the angle theta. So guys, to find R, we just use the Pythagorean theorem. R square is 1 over radical 2 squared plus negative 1 over radical 2 squared. And when we simplify this, we get R square equals to 1/2 plus 1/2, which is just 1. And we take the square root on both sides because we have to find R from R square, but square root of 1 is also going to be just simply 1. So my R is 1. Now I have all the three sides kind of this triangle, and from that information we should be able to find the theta. So how do we do that, guys? First of all, I start writing the cosine of theta. Cosine of theta we know is the ratio of the x over r, right? X over r. When we think of any angle, guys, if we confine it to a right triangle, then we think more in terms of the opposite and adjacent and the hypotenuse. But when we when we are looking at any angle greater than the 90-degree angle, then we like to think in terms of x, y, and r, and we base our trig ratios based on x, y, and r. X is going to be my horizontal or the real axis, y is going to be the imaginary or the vertical axis, and r is basically you can think of that as the radius of that circle, or you can also think of that as the hypotenuse. So x over r, it's going to be 1 over radical 2 divided by 1, which is just going to be 1 over radical 2, but we don't like to have the square roots or radicals in the denominator, so we are going to rationalize, multiply by upstairs and downstairs by radical 2. What we get? Radical 2 over 2. That is the cosine value. And then we also need to write the sine. Sine is also going to be, sine is basically y over r, and y here is negative 1 over radical 2 over 1. Same thing, guys, negative 1 over radical 2, you got to multiply upstairs and downstairs by the square root of 2, which is basically rationalizing the denominator. When we do that, we get negative radical 2 over 2. So we have the cosine and sine, and it is in the fourth quadrant. So this is radical 2 over 2 and negative radical 2 over 2. Now we have to look at the unit circle, and I'm going to do the same. I'm going to look at my unit circle, and from the unit circle, I can see that for angle 315 degrees, cosine is this and the sine is negative radical 2 over 2. So I'm going to write 315. So we can go back and write this in the polar form. R is 1. Okay, I can write that 1 here, but then later we don't even have to write that 1. And it's, guys, cosine of 315, because let me write that angle here. The theta that we found was 315 degrees. Okay, looking at the unit circle, 315 degrees plus I times sine of, same thing, 315 degrees. Guys, I'm going to preserve this, and I'm going to get rid of the rest of the information because we need more room to finally transform this raised to the power 12 into a standard form, or into a form where we can clearly see the real part and the imaginary part. So guys, this, I'm going to get rid of all this. Now we have this standard form transformed into the polar form. Now I'll raise it to the power 12. So this is going to look like cosine of 315 plus I times sine of 315, and we got to raise it to the power 12. And now we are going to simplify. Now again, we are not going to multiply this 12 times. That's a lot of work, and we don't really need to do all that. We have this nice theorem which says that when we have a trig form of a complex number raised to the power any integer n, then what we do is we basically raise the the absolute value raised to that particular power. Here the absolute value is 1. 1 to the power 12 is still 1, so we don't have to really write it. But then let us see what happens with the angles. Guys, this angle theta is multiplied by that exponent, and we're going to do the same thing with this. Each angle here will be multiplied by the exponent, which in this case is 12. So this is going to be cosine of 315 times 12 plus I times sine of 300 and same thing 315. Guys, I just simply use the Moivre's theorem, which I have written out right here. Okay. And now let us simplify further. This is cosine of 315 times 12. I'm going to look back into my notes, what I have here. Okay, what do I have here? 3780 plus I times sine of, same thing, 3780. Guys, we still have to simplify, right? We still have to simplify this. So there are a few ways to simplifying this. One, sometimes people just use the calculator for that. That might work out sometime. But guys, if we want to leave the answers with integer values or radicals, and we don't want the decimals, then one sometimes has to look at the unit circle. But looking at this big angle, we cannot directly see on the unit circle. So how can we identify what is the appropriate coterminal angle between 0 and 360, which is equivalent to this angle? And then we can look at the unit circle and figure out the values for the cosine and the sine. Guys, again, there might be a few different ways of finding that coterminal angle. My way is, guys, I divide this number by 360. So if it is not completely divisible, then I go to the nearest integer. So in this case, when I divide this by 360, I go up to 10. So 360. So 360, I'm going to divide 3780 by that. So I go up to 10. So I get 3600. And I'm left with 180. So what does that mean? That means I have to go around this unit circle 10 times. So if I go around the unit circle 10 times 1, 2, and 3, and 4, and 5, and 6, 7, 8, 9, 10, let us say. So when I go 10 times, I get back here, right? I get back to this 0, this reference side, right? Which is equivalent to 2 pi or 360 degrees, or equivalent to 0 degrees. So this is 3600 degrees. But guys, we want 3780. To get to 3780, we have to go 180 degrees further. So going 180 degrees further means from here, I have to go up to here. So finally, it is coterminal with this side. And we know this side makes an angle of 180 degrees, right? So this is what we are looking at. So the coterminal angle for this angle would be 180. So it's cosine of 180 Guys, first I write that coterminal angle, which is between 0 and 360, and then I look at the unit circle to substitute the values. And the second one is going to be same thing, but it's the sine, I times sine of 180 degrees. Now, once we figure this out, we are going to, I think we need a little more room to kind of finish doing this. So guys, I can get rid of this. You already understood the whole idea. Guys, I like to draw this so that I can see a clear picture. If you don't want to draw it, it's up to you. Guys, it becomes easier for me to actually solve this example by actually drawing these visuals sometimes when needed. So from here, I'm going to look at my unit circle. From the unit circle, cosine of 180 degrees is going to be -1. Times I times sine of 180 is 0, so it is finally -1. If you want to leave it as one single number, otherwise you can also leave it like this. Here you can clearly see the real part, which is -1, and the imaginary part, which is 0. And guys, even with this, one should know that the real part is -1, and the imaginary part, which is not visible here, but there's always that plus invisible plus I times 0, so 0 is my imaginary part. So guys, this is how we simplify this. Now it's raised to the power 12. It could be raised to the power 100. We're still going to do the same thing. We're going to first transform this into the polar or the trig form. Then we're going to use this nice Moivre's theorem and then simplify. Okay, guys, keep practicing these problems. If you have any questions in this section where we are transforming from standard to the polar form and then raising it to some power, feel free to reach out to me. I'll be more than happy to actually solve those problems, or I can give you some hints on those. Guys, till next time, take care. I will see you next time.